Hi, this is Kalaivani from Chemistry Department. Today I am going to discuss about the structural elucidation of citral. So citral means citral or it's chemically named 3,7 dimethyl 2,6 octadienyl or lemonenal. So it is derived from the lemongrass. So that only we get the name lemonenal. It is either a pair or a mixture of terpenoids with the molecular formula C10H16O. The two compounds are double bond isomers, so then only it belongs to the terpenoids. An E isomer is known as geranyl or citral A, and Z isomer is known as neral or citral B. So here we have to classify it into two types. One is citral A and another one is citral B. Due to cis-trans isomerism at the C double bond C bond, nearly the aldehyde group obtained from essential oils of plant sources. So the isomer general has strong lemon odor. The isomer neral has lemon odor is less strong and sweeter. So the isoprene units of citral is an alpha beta unsaturated aldehyde classified as a monoterpenoid compound from the 3,6 dimethyl octane series and characterized by head-to-tail linkages of two isoprene subunits. We know that already head-to-tail, head-to-head and tail-to-head linkage, but citral belongs to the head-to-tail linkage of two isoprenoid units. Next, we have discussed about the physical properties of citral. So, citral is a clear yellow colored liquid with a lemon-like odor, less dense than water and is insoluble in water. Its melting point of citral is less than 10 degrees Celsius. Density of citral is 0.9 gram per centimeter cube. Citral is not stable to alkanes and strong acid. When heated to decompose, it emits acrid smoke and irritating fumes. So where they are occurrence? Citral is mainly present in the oils of several plants including lemon, myrtle, and it is easily cultivated in Australia for flavoring and essential oil. It is the highest natural source of citral. And citral as an isolate in steam distilled lemon myrtle oil is typically 90 to 98% is occurrence. Next, lemongrass. So lemongrass is also a occurrence of citral. It is cultivated in India, Southeast Asia and Africa. Lemongrass is a good source of lemongrass oil, which is a good source of natural citral. So lemongrass oil contains 85 to 65 percentage of citral. Third one, its occurrence in lemon tree. It is grown in plantation in Kenya, South Africa and Australia. The essential oil of tea tree contains 70 to 80% citral. Next, it's a lemon balm. The lemon balm contains only 11% of citral. It is mostly cultivated in South Central Europe, North Africa and Mediterranean region and Central Asia. So next topic is isolation of citral. So citral is isolated from lemongrass oil which is obtained from lemongrass by steam distillation. We know that we have the isolation of essential oil is taken from the four important methods now, but here we have to use steam distillation. So what are the methods? So lemongrass, when chopped or unchopped, it is filled in the distillation flask and fitted tightly so that the vapors and oil was not leaked out. Now the steam is injected into it so that the upcoming steam carries away the essential oil from the plant material. Then the lemongrass oil as well as the vapors are passed through the condenser where they condense as the oil is lighter. Then water, so it will float through the surface of water and it is then easily separated. Now thus the obtained is the lemongrass oil which contain 85% of citral. So this is the diagrammatic features of explaining the above slide. So this is the distillation process. Next, structural elucidation of citral. So what are the constitution of citral? First, we have to discuss the molecular formula. We know that C10H16O. Next, presence of two double bond. So, in citral is treated with bromine on hydrogen, it forms citral tetrabromide. So, from the tetrabromide, we have confirmed that it has two double bond is present. So, indicating the presence of two double bond. So, citral and ozonolysis yield acetone and levanaldehyde and glycol. It is indicated citral is an acyclic compound containing two double bond. And presence of an aldehyde group. Third confirmation is the presence of an aldehyde group. The formation of oxime with hydroxylamine indicates the presence of an oxo group in citral. And citral on reduction with sodium or in the presence of mercury, it gives an alcohol called geraniol. On oxidation with the silver oxide to yield a geranic acid with the same number of carbon atom as citral. It indicates the oxo group is citral is an aldehyde group. So this is the reaction, its confirmation for it's an aldehyde group. Citral is an acyclic compound. So how it is confirmed? The formation of above products show that citral is an acyclic compound containing two double bonds. Corresponding saturated hydrocarbons of citral, that is molecular formula is C10H22, corresponds to the general formula CnH2n plus 2 for alicyclic compounds, indicating that citral must be an acyclic compound. So this is the main confirmation for getting acyclic compound. Next one, carbon skeleton of citral. How to say it's a skeleton of citral? So citral is heated with potassium hydrogen sulfate. It gives paracymene. It's a known compound. So the formation of paracymene and product obtained from the ozonolysis reveals that carbon skeleton 1 of citral is, that is structure 1 of citral is formed by the joining of two isoprene units in head to tail fashion. Already we know that citral is a head to tail fashion. So this is the evidence for that linkages. The formation of paracymene also reveals the position of methyl and isopropyl group in citral. So this is the carbon skeletal of citral. It gives the paracymene. This is the structure 1. So next, oxidation. So now we have discussed about this structure 2. Citral undergo oxidation with KM14 allowed by the chromic acid yield acetone, oxalic acid and lewic acid. These reactions are only explained if the citral has structure 2. So from this we have, from the reaction we have to get structure 1 and structure 2. So now we have to confirmation which structure is correct. So this slide shows support for the structure 2. It's among the two structure, the structure 2 is correct for the citral. Where it's very found that citral on boiling with aqueous potassium carbonate yielded 6-methyl-hep-5-ene 2-one and acetaldehyde. The formation of these can only be explained on the basis of proposed structure of citral 2 if it is undergoes cleavage at alpha-beta double bond. Further, methylheptanone undergo oxidation yields acetone and lewic acid. This can be only explained on the basis of structure 2. So this is this evidence of getting structure 2 is the correct structure of citral. So this is the structure 2 citral. It's forming the 6-methyl-5-ene 2-one and then it's lewic acid and acetone. The confirmation synthesis of citral by Barbier, further it is confirmed by the Barbier-Benoit-Tiemann synthesis. In the synthesis, methylheptanone is converted into generic ester by using Reformsky reaction. The generic ester is then converted to citral by distilling a mixture of calcium, salts of generic and formic acid. So this is the slide shows the it's a synthesis process of evidence of the citral. Next, isomerism of citral. Already we know that there are two isomers. The two diametrical isomers occurs in nature. The two isomers are different in the arrangement of aldehyde group about double bond in 2,3 position. One is cis-citral, another or neural, or other is a sans-citral or geraniol. So thank you for watching this video. Thank you.